Hello everyone, this is Mohammad Jahangir Hossain from MJH Math Assist. Today we are going to solve Cambridge International AS and A-Level Mathematics Paper 5 S1 May June 23 version variant 52. Okay, without further ado, let's start directly with the question paper. This is the paper May June 23 variant 52. Let's start directly. Start with the question one. You see in question one, the random variable x takes the values -2, 2, and 3. It is given that probability of x is defined as k times x squared minus 1, where k is a constant. You have to draw up the probability distribution table for x, giving the probabilities as numerical fraction. Okay, so to find the probability distribution, you first need the value of k. To find the value of k, the sum of the probability equals to 1. So let's use this one. Let us use this one to find the value of k. Sum of probability of all the values of x equals to 1. So from this one, you have when x is -2, the probability is k times 4 minus 1, that's 3k. When k is 2, the probability is 3k as well. And when k is 3, the probability is 8k. So sum of these three is equal to 1. So we have k equal to 1 by 14. Once you know the value of k, then you form the probability distribution table. So in probability distribution table, we need to state the value of x, all the values of x, and corresponding value of the probability. When x is -2, the probability is 3k, so that's 3 by 14. For 2, probability is 3k as well, 3 by 14. And when x is 3, probability is 8k, so it is 8 by 14, or you can also write it as 4 by 7. Okay? So that's the probability distribution table, and we have given the probability as numerical fraction. Now let's move on to the second part. In the second part, you have to find EX and the variance X. Okay, so for finding EX, you know the formula for EX is sum of the product of X times probability. So it is -2 into 3 by 14 plus 2 into 3 by 14 plus 3 into 8 by 14. This one is equal to, this is equal to 12 by 7. So that is 12 by 7. Now, to find the variance of x, the variance of x is for x e x squared minus ex, that's the mean, whole square. So to find ex square, the formula summation of x square into x probability minus ax whole square. Now find it. Summation of x square. X is -2, x square minus 2 square into 3 by 14 plus 2 square into 3 by 14 plus 3 square into 8 by 14 minus mean, which is 12 by 7. Ex is 12 by 7, which is the mean as well. Okay. Okay. So this will give the variance for x. Variance, you can call it variance of x, or you can call it in short form var x, which is, if you keep it in exact fraction, in proper fraction, then it is 192 by 49. And keep it correct to 3 decimal places, or 3.92. You can keep it as mixed form, which is 345 by 92. 45 by 49, not 92, I bet. So that's by X. That's question one. Now let's move on to question number two. In question two, it says, our sports event is taking place for 4 days beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, probability that it will rain is 0.7 if it rained on the previous day, and 0.2 if it did not rain on the previous day. Find the probability that it does not rain on any of the 4 days of the event. Does not rain. So, not rain on the first day, not rain on the second day, not rain on the third day, not rain on the fourth day. On the first day, on the Sunday, probability of raining is 0.4. So, not raining is 0.6. 1 minus 0.4, that is 0.6. So, probability, if we write it directly, it will be on Sunday, probability of not raining is 0.6. On the next day, since it did not rain on Sunday, the probability of rain on Monday is 0.2. So not rain, probability of not rain is 0.8. Then probability of not rain in the next day, same as 0.8 because it did not rain on Monday. 0.8 to 0.8 as well. So that's the probability, which is if you keep it correct to in exact decimal, it will be 0.3072. I mean, if you write down all the digits, or if you can even keep it in fraction, which will be, or you can keep it exact fraction, it will be 192 divided by 625. Okay, that's part A. Now, let's move on to the next part. In the next part, we see find the probability that the first day on which it rains during the event is Tuesday. The first rain on Tuesday. So not rain on Sunday, not rain on Monday, and rain on Tuesday, on the third day. Yeah, rain. So we have to find this probability. So this probability is it rained, it did not rain on Sunday. On the first day, Sunday, probability of raining is 0.4, so not rain 0.6. And probability of rain on Monday, since it did not rain on Sunday, is 0.2. So not rain 0.8. The next day, it did not rain on Monday, so probability of rain on Tuesday is 0.2. So that's the probability, which will be 0.096, or if you keep it in exact fraction, it will be 12 by 125. That's part B. Is there any further part in this? Yes, there is another part. Part C. In part C, find the probability that it rains on exactly one of the 4 days of the event. In that case, then the probability is not constant for raining all 4 days. So let's keep it simple. Let's find all the four possible scenario in which exactly one of the day it rains. So let's say it rains on Sunday. So rain on the first day, not rain on the next 3 days, not rain. So that's the first possibility. And the second one, here the probability will be, how much is the probability rain on Sunday? That's 0.4. Isn't it 0.4? Yes, it is. And it rained on Sunday, probability of rain on the next day is 0.7. Yes, 0.7, so not rain. 0.3, it did not rain on Monday, the probability of not rain on Tuesday is 0.8 into 0.8. And for your help, you can keep it as it rained, it rained on the previous day. previous day, its probability 0.7. Rain given did not rain on previous day, probability 0.2. That will help. Then next scenario is, let's say it rains on Monday, not rain on Sunday, rains on Monday, does not rain on Tuesday and Wednesday. So not rain on Sunday, rain on Monday, 0.2, rain, so not rained on the next day, 0.3, not rain, so not rain next day, 0.8. Then rain on Tuesday. So it will be 0.6, 0.8, 0.2, 0. Then we may there's the rain on Wednesday, the fourth day. So not rain, not rain, not rain, and finally it rains. So these are the four possible scenarios in which it rains on exactly one of the 4 days of the event. So you add up all these probability, you get the probability of rains on exactly one of the day of the 4 days, which will be, you add all this three, all this four, you have 0.2112, or keep it in exact fraction, it will be 132 by 625. Okay, that's part C. Now let's move on to the next question. The next question, we have question 3. We have a back-to-back same and leaf diagram. And this same and leaf diagram represents the monthly salaries in dollars of the 27 employees at each of the two companies, A and B. And the T is 27 in the same on the leaf, 1 on the left side, 6 on the right-hand side. Right side means 2710 for company A and 2760 for company B. We have to find the median and the interquartile range of the monthly salaries of the employees in company A. Here, we are not going in detail how to read the numbers from the stem and leaf diagram. Rather, let's assume we can read the information from the stem and leaf diagram, and we are going directly to find the median and the interquartile range. Say the median, we'll find the median and IQR for company A. For company A, median will be the middle number, right? We have total 27 employees, so middle number is 14th employee. 14th observation is the median. So which one is the 14th observation? You see, we have 5 here, we have 7 here, 12. So 14 is this one. 2710 is the median. 2710 dollar is the median salary of the employees in company A. Then to find the IQR, the IQR is Q3 minus Q1. Now we have 13 salaries below this median and 13 salaries above this median. So Q1, Q3 will be the middle of the salaries. Above it, that is 13. The middle value is 7. So 1, 2, 3, 4, 5, 6, 7. So Q3 is 2840 minus Q1. Q1 is 7 here, 2610. So see, there are 13 below the median. So middle value of the 13th observation is 7th observation. So if you count it from the beginning, 1, 2, 3, 4, 5, 6, 7. So that's 7, 2, 6, 1, 0. That's the Q1. So difference of these is $230. That's the IQR for company B. Now that's Q median and the IQR for company A. Now let's move on to the next part. The next part, the lower quartile, median, and upper quartile for company B are 2600, 2690, 2780 respectively. Now, draw two box and whisker plots in a single diagram to represent the information for the salaries of employees at companies A and companies B. And for this, we have to scale this graph first. You see the lowest value of salary for company A is 2500. That's 2500, and highest one is 3010. And for company B, it is 3090. Let's say it's 3100. So we need to label from 2500 to 3100 on the right one. Let's say this is 2500, this is 26, 27, 28, 2900, 30, 31. Okay. Now, let's plot the box plot for company A above the box plot for company B. For company A, the Q1 is 2610. 2610, that's 2600. And let's say here we go. That's 2610. And Q2 for company A is 2710. That's 2710. And Q3 is 2840. 2840. Let's complete the box here. And the lowest salary for company A is 2500. Highest salary 3010. So 2500, and the highest salary up to 3010. Okay, that's the box plot for company A. Okay, now let's complete the box plot for company B. The Q1 for company B is 2600. 2600, and Q2 is 2690, Q3 2780. Okay, 600, 2690, 780. Highest salary for company B is 3090, 3090, and the lowest salary for company B is 2540, 2540. So this is the box square float for company B. Okay, these are the two box plots. Now that's part B. Now what you have to do in part C, you have to comment on whether the mean would be a more appropriate measure than the median for comparing the given information or for the two companies. If you look at the diagram, although uh, the salaries for company B, if you look at the box plot, it is symmetrical, just looking at the box. But if you look at the whisker, you see the right whisker is more spread out compared to the left whisker for company B. The same goes for company A, and the boxes are not symmetric for company A. So both company, the distribution is not symmetric completely. And if you look at the data given for company B, there is an extreme value because the salary of 3090 is obviously different from the other salaries of the employees in company B. So in both company, the salary is affected by skewness, that is extreme value. So mean is not an appropriate measure or to compare the salary information of the two companies. Rather, it will be median because median will be least affected by the extreme value, by the skewness of the distribution. So median is more appropriate. So right here, the median is more appropriate. Mean is less appropriate measure as there is extreme value in company B. All right, that's part three. That's the end of this question. Now let's move on to the next question. It's number four. In question four, you see a pair five-sided spinner has sides labeled 1, 2, 3, 4, 5. Its pair is either and five-sided, so probability of each score is equally likely, which is 1 by 5. The spinner is spun repeatedly until a 2 is obtained on one side on which the spinner lands. The random variable x denotes the number of spins required. So here, the total number of spins is not fixed. We'll spin it repeatedly until we obtain a 2. So obviously, here it is not binomial distribution, so it is a geometric distribution. So x follows geometric distribution and the probability of scoring 2 is 1 by 5 and the number of spins required to obtain 4 2 is 4. So x 4 probability 1 by 5 into 1 minus 1 by 5 for on first three spin, we got not two. So probability is 1 minus 1 by 5 to the power 4 minus 1, that's 3. That's the probability of this one. If you write in decimal, it will be 0.1024, or you can keep it in exact fraction, which will be 64 by 625. Now, in part B, you have to calculate what is the probability that total number of spin required is less than 6. So x less than 6. Since it is a geometric distribution, you can use the direct formula for geometric distribution. X less than r is 1 minus x less than equal to r. It is 1 minus q to the power r. So here we have x less than 6, that is x less than equal to 5. You can use directly to the formula 1 minus q, which is 1 minus the probability to the power r, that's 5. So that will give you either 0. If you keep it correct to ESF 0.672, or if you keep it in exact fraction, it will be 2101, thereby 3125. That's part B. Now, what is in part C? So I think it is clear for part A and part B. So let's move on to the next part. In next part, two pair five-sided spinners, each with sides level 1, 2, 3, 4, 5 are spun at the same time. So here we are spinning two pair five-sided spinners. If the numbers obtained are equal, the score is 0. Otherwise, the score is the higher number minus the lower number. So that is the difference of the scores if the scores are not equal. Find the probability that is the score is greater than 0, given that the score is not equal to 0. So it's a bit complicated one. Why don't we draw the possibility diagram first? Okay, let's say the score of the first spinner above 1, 2, 3, 4, 5. And score of the second spinner, let's keep it vertical, 4, 5. Okay. So we have a total of 25 different outcomes. The outcome where both spinners score same number, the score is both spinner obtain same number, the score is 0. Otherwise, the score is the difference of the two numbers. Here, so 0 will be here. Here we have 0 here. 2, 2, 0, 3, 2, we have 0, 4, 4, we have 0, 5, 5, we have 0 here as well. Here, the score is 1 and 2, so difference 1, here 1, 3, difference 2, here 1, 4, difference 3, 5, 1, difference 4, here 2, 1, difference 1, 1, 2, 2, 0, 3, 2, difference 1, 4, 2, difference 2, 5, 2, difference 3. Here, the score is 1, 3. The outcome is 1, 3. So score is 1, 3 minus 1, 2. 2, 3, 1 is 3, 0. Then we have 4, 3. Score is 1. 5, 3. Score is 2. Here, so outcome is 1, 4. Difference is 3. Here, outcome is 2, 4. Difference 2. 1, 0, 1. So we see there is a sequence 4, 3, 2, 1. Now, let's say greater than 0, 4 is greater than 0, that event A greater than the 0 are here. how many outcome we have? This is the outcomes where the score is greater than 0. There are total of uh, 4, 3, 2, 1. 4, 3, 2, 1. That's 10. 10 on the above and 10 on the below. So 20. The probability of scoring, probability score greater than 0 is 20 out of 25 out. And not equal to 2. In how many cases we have the score equal to 2? So these are the cases. There are 6 outcomes where the score is equal to 2. So not equal to 2 will be 25 minus 6. Score not equal to 2. 25 minus 6, that's 19 by 25. Now, if you consider what we have to find, probability of score greater than 0 is greater than 0, given that the score not equal to. So, if you follow the formula here, remember probability of A given B, probability of A given B is in the denominator we write probability of B, and the numerator we write probability of the intersection of the two events. The given condition will be in the denominator, probability of the given condition. The probability of S not equal to Q in the denominator, and the numerator we have to find the probability of S greater than 0 intersection S not equal to Q. Now, in how many of the events this score is greater than 0 and not equal to 2? Obviously, you see these are the 1, 2, 3, 4, 5, 6, 7. 7 and 7 here. So total 14. 14 by 25. So 14 by 25 and not equal to 2 is 19 by 25. So answer is 14 by 19. That's the probability that the score is greater than 0, given that the score is not equal to 2. So wherever this equation is confusing, you better use the help of the diagram. Here we are using here this sample space diagram, probability, possibility diagram. Okay. Now let's move on to the next question. Now there is another part. Next part. The two spiners are spun at the same time repeating. Here we are spinning it repeatedly for a 9 randomly chosen spin. So now we are limiting the number of spin, which is exactly 9. Of the two spinners, find the probability that the score is greater than 2 on at least 3 occasions. What will be the probability of the score greater than 2 on the spins of the two spinners? You see, score greater than 2, that is, score is can be 3, can be 4. So there are total of 6 outcomes where score is greater than 3 on a single spin of the two spinners. So it is 6 by 25. Now, so we have P is 6 by 25. And We have total of 9 spins, the two spinners, and you have to find that the score is greater than 2 on at least 3 occasions. So here the variable is number. Let's denote it by y, and y denotes the number of occasions where score is greater than 2. In that case, probability is 6 by 25, and the number of tails or number of spins is 9. So it follows a binomial distribution. By that, it's binomial distribution, not geometric. So n is 9, probability is 6 by 25. Now, I have to find where the number of occasions is at least 3, number of spin is at least 3, where the score is greater than 2, at least 3. So there are how many? Yes, 3, 4, 5, 6, 7, 8, 9. So only spins that we are excluding are 0, 1, and 2. So why don't we find 1 minus y equal to 0, 1, and 2. So probability of y equal to 0 is 6, and 9 c 0, c to the power 0, 1 minus p whole to the power 9 minus 0, that is 9 c 0, p 6 by 25 to the power 0, 1 minus p, that is 19 by 25 to the power 6. And probability of y equal to 1, 9c1, 6 by 25 to the power 1, 19 by 25 to the power 8, plus 9c2, 6 by 25 to the power 2, 19 by 25 to the power 7. So you calculate this one, and it will end up as, if you write the answer correctly, PSF, it will be 0.371. So that's the probability that the score is greater than 2 on at least 3 occasions. Okay, that's the end of this question. Now let's move on to the next question, which is question 5. See, in question 5, the length of western bluebirds are normally distributed with mean 16.5 centimeter and standard deviation 0.6 centimeter. A random sample of 150 of these birds is selected. How many of these 150 birds would you expect to have length between 15.4 centimeter and 16.8 centimeter? First of all, the length follows a normal distribution. So, what you have to find the number of how many of these 150 birds you expect to have the length between these two, 15.4 centimeter and 16.8 centimeter. To find the number of birds, first you need to find the probability where the length is between 15.4 centimeter and 16.8 centimeter. Then we will find the expected number of birds. So, first, the length follows normal distribution with mean 16.5 centimeter and standard deviation 0.6, so variance is 0.6 here. So to find the probability where length lies between 15.4 and 16.8. Okay. So convert it to Z 15.4 minus. Remember, for Z we have the formula x minus mean by standard deviation. So x is 15.4 minus mean 16.5 divided by standard deviation 0.6. 15.8 minus 16.5 divided by standard deviation 0.6. So we calculate this one. We have Z here, that is minus 1.8. We keep the value of Z characteristic decimal places 0.5. Now, see the probability is Z less than the upper limit, probability of closed region. Remember, whenever we have probability of Z between A and B, how do you find it out? Probability of Z less than the upper limit minus Z less than the lower limit. So here it will be Z less than 0.5 minus probability Z less than minus 1.833. So Z less than 0.5, that is 0.6915 minus Z less than negative. So 1 minus, that will be 1 minus Z less than positive. Z less than negative minus 1.8, negative 1.833. So the probability will be 1 minus probability Z less than positive 1.833. So it is 0.966. You can find it out from the table. Here you have the normal distribution function, and the table is the 1.8333. And if you look at the table, 1.83 is here, 1.83 here, and with this you have to add the value for 3 is 2, the end of this, that is 0.9664 plus 0.0002, which will be 0.9666. So that's how we have got here 0.9666. And you add, if you calculate this one, you write it correct to CSS, so it will be 0.658. That's the probability. Now, expected number of parts whose length lies between these two, 15.4 centimeter and 16.8 centimeter, will be total number of birds times the probability. Total number of birds we have in the sample is 150. The probability is 0.658. So it will be 150 into 0.658 is 98.7. You can keep it as 98, or you can also write it and both of the both answer is accepted. So that's part A of question 5, where we have to find the expected number of birds with length lies between 15.4 centimeter and 16.8 centimeter. Now, the next part B. Here is the length of stern bluebird. Here we have different species and bluebirds, normally distributed with mean in 18.4 centimeter standard deviation unknown. It is known that 72% of the eastern bluebirds have length greater than 17.4 centimeter and 17.1 centimeter. Of course, you have to find the value of sigma. So here, let's say the variable is E for length of eastern bluebird follows normal distribution with mean 18.4 and standard deviation sigma, so variance is unknown sigma square. And now we know that the length greater than 17.1 and the probability is 72%, 2.72. So first you need to convert it into Z. Z greater than 17.1 minus 18.4 by sigma is 0.72. So we have negative here. So Z less than, since it is negative, minus 1.3, let's go minus 1.3 by sigma. So Z greater than negative Z is equal to Z less than positive 0.72. Now from the table, let's find where for which value of Z the probability is 0.72. We have 0.272 is 0.7190. The probability we know the probability here. We need to find the Z. 0.7190. We have to add 10 with this. And for this one, the value is the G is 0.583. 0.583. So we have 0.583. 1.3 by sigma 0.583. So sigma is 1.3 divided by 0.583. If you give it to 3 SF, it will be 2.23 centimeters. That's the value of sigma in this case. Now let's move on to the part C. In part C, we have random sample of 120 stern bluebirds. Random sample of 120 stern bluebirds is chosen. Use an approximation to find the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1 centimeter. So here the variable has 10. The variable is number of bluebirds which have length greater than 17.1 centimeter. So we are dealing with number of stern bluebirds that have length greater than 17.1 centimeter. In that case, we have a sample of 120 bluebirds. So number n is 120. Why? We are mentioning it as n because probability at the length greater than 17.1 centimeter, we know the probability, which is 72%. That's given in part B. So probability of that the bird have length greater than 17.1 1 centimeter is 0.72. And we have put up a sample of 120 stand bluebird. Now, so that number of tail is constant and probability is constant. So obviously it follows binomial distribution. The next thing is you have to find fewer than 80 blue. Fewer than 80 of this 120 blue birds have length greater than 17.1 centimeters. That you find the probability. Now you see n is large, so you cannot use the binomial distribution here to find the probability. You can, but it will take a lot of time, a lot of effort. And that's why you have to use an approximation. For this approximation, remember, we can approximate binomial distribution by normal approximation. In that case, both NP and NQ should be greater than 5. In fact, it is more than 5 in both cases. So, we can directly find the mean and variance of this binomial distribution. Mean is NP, which is 120 times 0.72, which is 86.4, and the variance NPQ or NP into 1 minus P, that will be 120 into 0.72 into 1 minus 0.72, that is 24.192. So you can approximate the binomial distribution by a normal distribution, where the variable will be x. We're using different variable because y it denotes the number of bluebirds, which is a discrete variable, where a normal distribution is continuous variable. That's why we are using different notation for these two variables. And the another reason is that since we are approximating normal distribution by approximating binomial distribution by normal distribution, so we need to do the continuity correction. So y less than 80, y less than 80, what will be the continuity correction here? Less than 80, that is y less than equal to 79. So y less than equal to 79. So from here, if you do the continuity correction, you have to extend it by 0.5. So x is greater than equal to 79.5. Now we have done the continuity correction. Next, the simple process of finding probability using normal distribution. Convert it into Z, it will be 29.5 minus mean divided by standard deviation. We know the variance, so standard deviation is the square root of this. So Z less than this, Z less than minus 1.403. That is 1 minus probability Z less than 1.40340 and we have to add 4. So 0.9196. 0.9196. So that is 0.0804. Correctly, 3 years left. That's the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1 centimeter. And that's the end of question 5. Now let's move on to the next question, question 6, which is in fact the last question of this paper. In question 6, we have in a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. A team of 7 people is selected. Team of 7 people is selected from these 25 people to take part in a competition. Find the number of different ways in which the team of 7 can be selected if it consists of exactly one swimmer, at least four cyclists, at most two runners. So first you have to find the possible number of the members of each segment. Let's say swimmer, let's denote swimmer by S, cyclist by C, runners by R. Exactly one swimmer. There will be exactly one swimmer and at least four cyclists, at most two runners. So exactly one swimmer, four cyclists, two runners. That's one of the possible teams. Now you can increase the number of cyclists. Number of cyclists can be five. In that case, runner is one. Then six. Number of runner can be zero because at most two runners. So these are the possible scenarios. Now, what is the number of ways? For this scenario, we have how many swimmers we have? Six. Among the six swimmers, we'll select one. 61 times per cyclist from 8. 8C or two runners from 11. 11C. Okay. That is 2, 3, 100. 23,100. Then we have one swimmer from six swimmers, 61, five cyclists from 8, 85, one runner from 11, 11C1, that is 3696. And here 61 times 86 into 11C0, that's 1. So it will be 168. The total number of ways can be 231,003,696 plus 168, which add up to 26960 or 964. Okay, that's part A. Number of different ways in which a team of 7 can be selected if it consists of exactly one swimmer, at least four cyclists, and at most two runners. Now, the next part, for another competition, a team of 9 people consists of two swimmers, three cyclists, four runners. Okay, the team members stand in a line for a photograph. How many different arrangements are there of the 9 people if the swimmers stand together, cyclists stand together, runners stand together? So we have three different groups: swimmers, cyclists, runners. So three groups can stand in a number of ways with factorial 3. The swimmers can rearrange among themselves, cyclists, so does the cyclist, so does the runner. So number of arrangement will be, so number of arrangement, first we arrange the three groups, factorial 3 times the swimmers can arrange themselves rearrange themselves in a number of ways, factorial 2. The cyclist, factorial 3, and this runner, factorial 4. So that's the total number of different arrangements, which is 1728. So here, group swimmer, cyclist, runner. Okay, so that's part B. Now let's move on to the next part. Yes, there is another part C. In part C, how many different arrangements are there of the nine people if none of the cyclists stand next to each other? Remember, the cyclists, none of the cyclists. How many cyclists we have in this group of nine? Three cyclists. So let's keep it. Two swimmers, three cyclists, two cyclists, and four runners. Remember, the cyclist does not stand next to each other. So forget the cyclist. How many? If we exclude the cyclist, we have total of six members in the group. So if we arrange the six members first, one, two, three, four, five, six. You can arrange the six members first. Then, if the cyclists do not stand next to each other, then there will be possible positions. How many possible positions for the cyclist? After you arrange the remaining six, so we have total of one, two, three, four, five, six, seven. Seven possible positions for the cyclist, where if they stand in this seven possible position, the cyclist will not stand next to each other. So, so what we are finding here, first finding the number of arrangements of the people except the cyclist, number of arrangements. We have six different people apart from the cyclist. So we can arrange them with actual six different ways. Then we have seven possible positions for the cyclist. Among them, we place three of them in three positions in P72 ways. So spectral 6 times 7 PC, that will give you the number of different arrangements where the cyclists will not stand next to each other. And that number of arrangement is 151200. That's the number of arrangements. Okay, so there we have non-cyclists. Non-cyclists, pick non-cyclists first. Then we have seven different positions for the non-cyclists, and we need to place three of them in any three of these positions. So 73 ways times the arrangement of the six cyclists spectrum 6. So that's the number of different arrangements where the cyclists do not stand next to each other. That's part 3. Okay, that's it. That's the end of this paper. If you guys have any queries, please mention it in the comment section. I will try to reply as soon as possible. Okay, that's it for today. See you in the next video. Until then, Allah Hafiz. Assalamu alaikum. Fi amanillah. And don't forget to subscribe and hit the like. Thank you.